What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Security Plus certification exams. So let's get into it. In this video, we're diving into an essential topic for anyone preparing for the CompTIA Security Plus exam. We're going to be talking about applying common security techniques to computing resources. And this is a practical and highly relevant discussion because these techniques form the backbone of securing modern IT environments. So with that being said, let's get started. All right, so let's kick things off with secure baselines. So think of a baseline as your starting point, the default configuration of a system or environment that meets your organization's security requirements. Establishing, deploying, and maintaining these baselines ensures consistency and helps mitigate vulnerabilities. So let's talk about how this all happens. So first thing we want to do is establish it. So you want to start by establishing system requirements, including hardware, software, and network configurations. You want to collaborate with stakeholders to ensure compliance with regulatory requirements such as PCI DSS, HIPAA, or GDPR, and you want to use configuration management tools like Ansible or Chef to document your baseline settings. Next, you want to deploy or roll out the configurations. So you want to roll out the baseline configurations using automation tools or scripts to ensure accuracy and efficiency, and you want to test the deployment in a sandbox environment to identify potential conflicts. And then next, you want to maintain or adapt over time. So periodically, you want to review and update baselines to adapt to evolving threats or software updates. You want to use tools like Microsoft Group Policy for Windows environments or System Center Configuration Manager. So the thing is, consistency is the key. Secure baselines should be repeatable and well documented to handle changes or scaling needs efficiently. All right, next let's talk about hardening targets. So this involves securing individual components in your IT infrastructure to reduce vulnerabilities. And each type of system has its own unique requirements. So let's talk about mobile devices. So you want to ensure strong passcodes, biometric authentication, and device encryption. You want to enable remote wipe and lock features via the mobile device management system. Then we have workstations. You want to apply endpoint protection tools like antivirus and anti-malware. You want to disable unnecessary services and ports, and you want to regularly apply operating system and application updates. Then we have switches and routers. You want to change default credentials immediately. You want to disable unused ports and enable MAC address filtering. And you want to implement network segmentation using VLANs. Then we have cloud infrastructure. So you want to use role-based access control to restrict permissions. You want to enable logging and monitoring via cloud-native tools like AWS CloudTrail or Azure Monitor. Then we have servers. So you want to disable unused accounts and implement multi-factor authentication. You want to encrypt sensitive data at rest and in transit. And you want to regularly audit user activity logs. Then we have ICS and SCADA systems. You want to physically isolate systems wherever possible. You want to monitor traffic for anomalies with intrusion detection systems. You want to limit remote access to secure tunnels like VPNs. Then we have embedded systems and RTOS. So you want to implement secure boot processes and firmware updates. And you also want to ensure physical tamper resistance. And then we have IoT devices. So you want to change default passwords and update the firmware. And you want to use network segmentation to isolate IoT devices from critical systems. So remember, hardening is an ongoing process. So you want to conduct regular audits that are crucial to identify and address any new vulnerability. All right, next let's talk about wireless devices. So wireless networks are integral but inherently more vulnerable, and proper installation and configuration are essential. So here are some installation considerations. The first one is site surveys. So you want to use tools like NetSpot to map out coverage areas and identify potential interference sources. You want to use heat maps. These visualize the signal strength and adjust access point placement to minimize dead zones. Then we have security settings. You want to enable Wi-Fi protected access 3 for strong encryption. You want to use AAA radius for centralized authentication and access control. You want to implement cryptographic protocols like AES for robust data protection. And you want to use authentication protocols like ETLS for secure connections. Next, let's talk about mobile solutions. So managing mobile devices securely is a multifaceted challenge. So let's explore some of the key aspects. And the first one is mobile device management, or MDM. And this centralizes control over mobile devices to enforce policies, deploy updates, and monitor compliance. And then we have various deployment models. And the first one is called BYOD, or bring your own device. And this allows personal devices, but enforces strict security policies. Another deployment model is called COPE, or corporate owned, personally enabled. This offers employees company devices with personal use allowed under strict monitoring. And then we have CYOD, or choose your own device, and employees, they can select from a pre-approved list of devices. Then we have what are called connection methods. So you want to ensure cellular connections use encrypted tunnels like VPNs. You want secure Wi-Fi networks with strong protocols, and you want to limit Bluetooth connections to trusted devices and disable them when they are not in use. All right, next we have application security. So applications are a common attack vector. So securing them, this requires proactive and reactive measures. So the first concept is input validation, and this ensures only acceptable data types and formats are processed. We have what are called secure cookies. They protect session data by enabling HTTP only and secure attributes. We have static code analysis. This uses tools like SonarQube to identify vulnerabilities in code before deployment. And then we have what is called code signing, and this digitally signs applications to ensure integrity and authenticity. All right, moving on, we're going to talk about sandboxing, and this involves isolating applications to limit their access to system resources. And this is crucial for testing potentially malicious code or applications. So you want to use technologies like Docker containers or virtual machines to implement sandboxing in your environment. And then finally, let's talk about monitoring and visibility. This is the key to maintaining security. So you want to use security information and event management, or SIEM systems like Splunk or Elk Stack. You want to set up real-time alerts for unusual activities, and you want to regularly review logs and reports for trends or anomalies. So in conclusion, this wraps up our discussion on applying common security techniques to computing resources, from establishing secure baselines to managing wireless and mobile devices. The techniques we discussed are fundamental for securing any IT environment. So remember, security is not a one-time effort. It's an ongoing process that requires vigilance and adaptation to new threats. Now, with all that being said, let's do some of this check on learning. So the first question is, what is the primary purpose of establishing a secure baseline in computing environments? Is it to ensure all devices use the same software versions? Is it to provide a starting point for system hardening and configuration management? Is it to automate the deployment of software patches? Or is it to monitor network traffic for anomalies? And the correct answer is, it is to provide a starting point for system hardening and configuration management. So a secure baseline, this is a reference point for system configurations that ensures systems are set up consistently with security best practices. It serves as a foundation for applying hardening measures, tracking changes, and maintaining security. Next question. Which of the following is the best practice for securing wireless networks in a corporate environment? Would it be using WPA2 with a pre-shared key for all employees? Would it be implementing WPA3 along with 802.1x authentication using Radius? Would it be configuring Wi-Fi networks to be open but monitor traffic for unauthorized access? Or would it be for disabling encryption on the network to improve performance? And the correct answer would be implementing WPA3 along with 802.1x authentication using Radius. So WPA3, this provides stronger encryption and security enhancements over WPA2, and using 802.1x authentication with Radius, this ensures secure and scalable identity-based access control for corporate environments. And our final question. What is the primary benefit of using a sandbox when analyzing suspicious applications? Is it prevents unauthorized users from executing the application? Is it isolates the application from the host system to prevent potential harm? Is it ensures that the application is executed in a cloud environment? Or is it automatically validates the application's code for vulnerabilities? And the correct answer would be it isolates the application from the host system to prevent potential harm. So sandboxing, this is a security technique that allows applications to run in an isolated environment, ensuring that any malicious behavior does not affect the host system or other resources. And this is particularly useful for analyzing untrusted software.